Hey guys, in today's lesson we're going to be talking about beam analysis and in particular beam stresses. I'm going to be giving you the civil engineer's guide to understanding these fundamentals in engineering. So firstly in this lesson I'm going to be talking about what actually are beams, how do we use them and how can we design them. I'm then going to show you some free open source web software that can be used to help solve engineering beam problems. So this can be useful for your work or your homework if you're a student. And finally, I'm going to actually dive into it in a lot more detail and explain the first principles, all of the definitions and how to do the hand calculations. So I won't just show you some software to help solve the problem, but I'll also help you give you the first principles understanding as well. So firstly, what are beams? So here you can see a variety of different steel beams that can be used in construction, but it's important to remember that it's not just steel beams necessarily. It could be wood or composite materials or concrete, and basically big structures like frames can be broken down into individual beam problems and you can solve them that way. So beams come up a lot, especially in structural engineering, and it's kind of a building block for lots of other stuff that gets used. So it's really important to have a good understanding of beam analysis if you want to be a structural engineer. And when you're talking about designing beams, typically you'll think about these three different things, although there are some other things you want to think about. The fundamentals are basically like bending moments, which is how the beam's bending, shear forces, which is how the beam's sort of being forced on like perpendicular to its span, and then also deflection, how much the beam's moving under the forces or the loads. So these are like three of the main things that people would check. And you can do this in different ways, but lots of the time at the beginning you can use charts and you can use mathematical calculations to actually solve these from first principles. So you can use these charts quite often with the most common beam configurations. You'll have charts showing them, and then you'll have a description or a sort of calculation that you can use, a template for finding the bending moments and the shear forces in these different cases. So it's maths in the fundamentals. It's all maths and mechanics. So here, what I'm going to show you now is some free engineering software, free open source engineering software. So if you go to calcforge.com, I'll put the link in the bio below, and you go to the free beam calculator tool. You can actually use this to solve a lot of the most common beam problems that you encounter. And it's all customizable and configurable, and basically you can use it to solve some of your homework if you have it as a student, or simple beams you need to design for work. So what you see here is you have different point loads which are being applied to this beam, and you can click to drag these around if you want to. You see this varying distributed loads. This is like a pressure acting over the beam. And you also have these point loads, which are your supports, which are acting underneath the beam to hold it up. You then below this have a chart which basically shows you what the bending moment looks like. So the bending varies across the beam, and this chart runs these calculations that you need to do in order to determine what the bending is across the length of the beam. You also have your shear force diagrams that you can see here with a summary of the maximum shear force and the minimum that's found along the length of the beam, and also the deflection. So this is how much the beam is moving under the applied forces. You also have a chart to show you this with a summary of the max and the min deflections. But let's say I want to actually customize this myself. I want to create my own version of this. So I can click this beam length button to enter my beam length. So let's say I want it to be 12. I think currently it's 10 meters. You'll see here the beam's now lengthened to 12. And I can also then edit the section properties. So if I click this section properties button, I'll actually then open up a panel for selecting which type of beam section I want to use, and this will adjust the overall deflection of the beam, how much it's moving. You can see here what we have is universal columns, universal beams, European sections, American sections, these different hollow sections as well, like square hollow sections, rectangular, circular. And you have a drop-down list of all of the common section sizes, all the standard section sizes. So let's say I want to use a universal column. I can click this button, and then I can go down to select, let's say, this 203 section. You'll see here that the bending moment's updated and the Young's modulus is also updated. Both of these are used to calculate the deflection. But I can also manually overwrite these if I want to. If I need to change, say, the Young's modulus, I'm using a different type of steel or a different material. And I can also click this button to consider the beam self-weight if I want to, and input that self-weight I'm using. But let's say I'm just happy with this, so I can click apply. I can then adjust my beam supports, so I can actually, you'll see here I've got beam support number 1 selected and beam support number 2 selected. Let's say I want another one that's actually in the center of the beam, so I can click new, and then I can click enter my position and click apply, and you'll see here this new support has just appeared. I can also set this as a spring support, which is basically it has some deflection before the support's activated. I'm not going to show you this one today though, but you can also use this if you need to. I can also add point loads, so I can add more point loads or delete them with this same panel and cycle between the different point loads I have applied, or change the magnitude. And then I can also change this distributed load. So this is like the red part, this pressure acting. So let's say I don't want it to be varying. I want it to be 10 kilonewton meters across the whole first section. So I can click apply, and then I'll basically see here that this is now not varying anymore. I can also delete them if I want to. So I can click delete and delete. And then you'll see here that now my distributed loads have gone, and I'm just left with the point loads, and also my charts will have all updated as well. I can finally also add, if I want to, some fixity on the ends of the different beams. So here I've added a fixed end connection, so this also basically provides some moment resistance as well as just providing resistance up and down, so it fixes the end in. And that's a very, very quick overview of how this software can be used to solve your common beam analysis problems that come up. And now what I'm going to do is I'm actually going to go into the details, explaining from first principles how these calculations work. Let's now take a look at the first principles of how these beam calculations actually work. For first-timers, seeing analysis like this is daunting. Even experienced civil engineers misunderstand these diagrams. But in the next 5 minutes, I'll give you everything you need to understand how these diagrams work and how you can create your own. But first, let's take a look at the first principles. Beams come in a wide range of shapes, sizes, and materials. When we apply a force to a beam, we generate internal forces inside the beam. There are 2 types of internal forces, normal forces and shear forces. Normal forces act along the length of the beam and act in compression or in tension. You can see here when we apply a force to the beam, we generate tension in the top of the beam when we're pulling the beam to a greater length, and compression in the bottom of the beam when we're squeezing the beam inwards. Shear forces are slightly easier to understand. They act parallel to the direction of the force being applied. We can simplify these 2 internal force components into what we call shear force and bending moment. We consider these 2 fundamentals in all beam analysis. Applied forces fall into 3 different categories. Point loads are where a force is applied to a single concentrated point on the beam. Distributed loads are where the force is spread over a length and acts as a pressure. Concentrated moment is where a pure moment acts on the beam in a given position. There are 3 types of supports: pin supports, roller supports, and fixed supports. The difference between how these supports act is in the way in which they restrain the movement of the beam. Pin supports restrain the beam in horizontal and vertical directions, whereas roller supports only provide support in one direction. Fixed supports provide restraint in the horizontal and vertical directions, and also provide restraint to bending moments. We need to follow certain stages when we analyse a beam. We need to first draw the free body force diagram. Then we follow 3 steps. First is calculating reactions, then bending moments and shear forces, and then finally deflection. We draw free body force diagrams where we draw the forces identified and the restraint locations. To calculate the reactions, we need to use equilibrium equations where the sum of the vertical and horizontal forces are zero and the sum of the moments is zero, meaning the beam is at rest. There are two cases when using equilibrium equations though. Statically determinate is where you create the same number of equations as unknowns, and therefore we're able to solve all the equations. However, statically indeterminate is harder, where you have more unknowns than solvable equations. In this case, you need to use more advanced calculations such as moment redistribution to solve the beam and to find all of these internal forces. After you've calculated the reactions, you can calculate the shear force. To calculate the shear force, you have to work from left to right across the beam and sum the reactions and applied forces at each point where they're applied. However, bending moment is slightly more complicated. Here again, you have to work from left to right and calculate the moments of everything left of each point where a support is located, and then work your way across the beam at each support location.